So welcome back to our Python programming fundamentals class. Before we learn something new today, let's spend a couple of minutes revising our previous lecture. Last class, we learned the fundamentals of Python. We understood what values are, different types of data types like integers, float, strings, booleans, how variables store data, the rules for naming variables, taking input from user using input function, displaying output using print function, and some basic operators. These concepts form the foundation of every Python program. Now, we are going to take to the next step. Let me ask you a simple question. Suppose you are developing a software for a college. A student enters his mark. If the value are greater than or equal to 40, then the result should display pass. Otherwise, it should display fail. Now think for a second. Can Python make this decision by itself? The answer is no. We have to teach Python how to make decisions. Just like humans make decisions every day. For example, if it is raining, we take an umbrella. If the traffic signal is green, we move. If our phone battery is low, we charge it. If today's lecture is interesting, hopefully nobody sleeps. Every decision depends on a condition. Similarly, programs also need conditions. Today's lecture is all about decision making in Python. By the end of today's class, you will be able to write programs that that does not just execute instructions one after the another. They will be able to think, compare values, and choose different paths based on the conditions. So before Python can make a decision, it must answer one specific question. Is the condition true or false? The condition that evaluates to either true or false is called a Boolean expression. So let's open the Python ideally. Give me a minute and type something 10 greater than 5. And if you hit enter, it says true. Ask like why did Python print true? Exactly because 10 is greater than 5. Now if I have 10 less than 5 and if I press enter again, the Python is checking whether that statement is true or false and it results in false. Let's try a few more examples together. 15 equal to 15. If I hit enter, it says true. Notice double equal to signs. Many beginners make mistake here. A single equal to is used to assign a value. For an example, 10 equal x equal to 10. But double equal to is used to compare two values. Let's verify it. 15 not equal to 20. It returns true because 15 is not equal to 20. Now one more. 20 is greater than equal to 25. It's false. Since 20 is not greater than or equal to 25, so comparison operators. So how is Python comparing these values? It uses something called comparative operators. Let's write them together. Operators such as equal to, not equal to, greater than, less than, greater than equal to, and less than equal to. So whenever you use these operators, the result will be always either true or false. That's why comparison operators are closely related to Boolean expressions. Now let's verify with one last example. Age equal to 18, print age greater than equal to 18. And if I hit enter, it says true. Now if we change value, age equal to 16, and if I run it again, age greater than or equal to 18, it returns false. See how just changing the value changes the decision. That's exactly how real applications work. A banking app, a shopping website, or an online exam portal all uses these comparisons to decide what should happen next. Now that Python knows how to check whether a condition is true or false, the next question is, how do we tell Python what to do when the condition is true? For that, Python provides its first decision-making statement, the if statement. Now, students sometimes check, students sometimes check true conditions is not enough. Let me ask you a question. Suppose a student wants to participate in a coding competitions. The rules are the students must have 75% of attendance and the students must have paid the registration fee. So now tell me, if the student has 90% but hasn't paid the fee, should it be allowed? The answer is no. If he paid the fee but now has only 50% of attendance, again, no. So what should happen? Both conditions must be true. This is where logical operators help us. So what are logical operators? Python provides three kinds of logical operators like and, or, not. Now we will understand each one with examples. Now if I have print 10 greater than 5 and 20 greater than 15. Here in this example, and operators returns true only when both conditions are true. Let's check the each conditions. Is 10 greater than 5? Yes, of course it's greater than. And if is 20 greater than 15? Yes, it of course. So as both the statements are true, the answer returns true. So if I save it and run, it returns true. Similarly, if I have small change here, instead of 20 greater than 15, I have 20 less than 15. So will this program return true? No, since one of the statement is returning false. So that's why while using and, it returns false. Think of an and as a locked door with two keys. Both keys are needed to open it. Now, suppose your college announcement. You can participate if you are from CSE or IT. You don't need both. One is enough. Let's verify it. So if I have print or 20 less than 15, one of the statement is false. Even though one of the statement is false, the Python returns true because at least one condition is true. So if I run, the Python returns true. But if I have both the conditions false, Python returns false. So I hope you understood the OR operator. Now, NOT operator simply reverses the result. For an example, inside print function I'm having not true. It displays false. And if I have not false, Python displays false. I mean true. Think of it like a switch. True becomes false and false becomes true. Now we know how to check conditions, but checking alone is not enough. Suppose I ask Python, is age greater than or equal to 18? Python replies, yes, it is true. Yes, that's good. But then what? We should what should Python do after getting true? That's where our first decision making statement comes in. The if statement tells Python if the condition is true, execute the block of code. Otherwise, simply skip it. The syntax will be if condition, colon, and then the statements. Notice something within that if, like if I when I hit enter from after you hit if conditions then colon, Python generally has four spaces and have statements within it. So this is considered as a block. Okay. Notice two important things. First, there is a colon after condition. Second, the next line is slightly shifted to right. This is called an indentation. Python uses indentation to identify which statement belongs to if block. If indentations are incorrect, Python immediately gives an error. This is one of the most common mistakes a beginners make. So let's write our first if program together. Age equal to int input, enter your age. And if age greater than or equal to 18, there I'll be having print you are eligible to vote. Now, if I save it and run, I'll be entering my age here, and let's see give input as 20, and if I hit enter, it says you are eligible to vote. But if I run it again with a different input like 15, what happened? Nothing printed. Why? Because the condition became false. If the if block was skipped, Python did exactly what we asked to do. So let's try with another example. Here I'll be having input marks. Enter your marks. If marks are greater than or equal to 40, print pass. I'm having marks as 55, then it results in pass. But if I run it again with a different value like 20, 28, again, no input. Students often ask, why didn't Python print fail? Excellent question. Because we never told to print fail. We only told to Python that if it what to do if condition becomes true. So naturally, when the condition becomes false, Python skips the block and continues with the next statement. So how do we tell Python what to do when the condition becomes false? This is exactly why Python provides if-else statement. We will learn if-else in the next section. So, students, in the previous section, we learned the if statement. The if statement works perfectly when we want to perform an action if the condition is true. But let me ask you a question. Suppose I write a program to check whether a student has passed. If the students are greater than, I mean, if the students' mark are greater than or equal to 40, I print pass. Now, suppose a student scores 25 marks. What should happen? So the program simply remains silent. No, the program should also tell the student he has failed. In other words, we need to tell Python what to do when the condition is false. That's exactly why Python provides if-else statement. The syntax is very simple. If condition, then statements, if true, then else, statement if false. So notice that both if and else end with a colon and both blocks are properly indented. Now let's write our first program for if else block. I am having marks equal to integer input, enter your marks. Then if marks are equal when greater than or equal to 40, I am printing you have passed. Else print sorry you failed. If I run it as like if I give input 65, it says you have passed. Now if I run it again with 22, it says sorry you have failed. See the difference earlier with only if. Nothing happened when the condition was false. Now using else, one of the two blocks is always executed. Let's solve with one more example. I'm having age as an input with enter your age as a prompt, and if age is greater than or equal to 18, print eligible to vote. Then else print not eligible to vote. If I enter 18, what will be printed? Then if I enter 17, what will happen? So this habit of predicting the output will improve your programming skills. So let's try it. If I enter 18, it says you are eligible to vote. But if I enter 17, it says not eligible to vote. So now that tell me, let me introduce another operation that is very useful in conditions. That is modulus operator. So it is represented with a percentage symbol. Now can anyone tell me what it does? It gives remainder after division. Let's verify it. So in this statement, I'm having print in modulus 3. And if I run it, it returns output 1 because 10 divided by 3 gives an quotient of 3 and a remainder of 1. Another example, print 20 modulus 5. It returns 0. Why? 20 is completely divisible by 5. So here is where modulus operators becomes really useful. Suppose I ask you to check whether it's even or odd. So how do we identify an even number? Exactly. If a number divided by 2 leaves a remainder of 0, it's even. Otherwise, it's odd. So let's write the program using modulus operator and if else statement. So I'm having a variable called num which gets input from the user, enter a number, then using if conditions, I will be printing whether a number is even or odd. So inside the if, I'm having num modulus 2 is equal to 0, then print even number. Otherwise, using else, print odd number. So if I run the program, it asks the user to enter a number and I enter 15. It returns odd number. And if I give to 12 as an input, it says even number. So this is one of the most frequent questions asked in programs like in interviews or lab exams. Make sure that you understood why you use model as symbol instead of division. So now observe something carefully. Suppose I remove int function which is just outside the input one, and if I do this thing again like 15, what does it return? It returns type error. Why? Because input always returns text. That's a string. But 15 is an integer. Python can't compare a string with an integer. So, because comparing numerical values, we convert the input into the required data type. This process is called typecasting. For integers, we use int. For float, we use float. For string, for text, we use str. So whenever you take numerical input from the user, always remember to convert it using int or float before performing calculations or comparisons. Now we have learned how to make a distance between two choices. But if the choices were 3, 4 or even 5, there will be different possibilities, right? So for an example, assigning grades like O, A plus, A, B plus, B based on marks. Should we write multiple separate if statements? There are better and more organized way. So that's what we will be learning in the next. That is if, elif and else statements. இல்லடா பாஸ் பண்ணிட்ட சொன்னேன். நேற்று 8 மணிக்கு தான் இருந்துச்சு. இன்னைக்கு 8 மணிக்கு தான் இருந்துச்சு. ஏசி மழை பெஞ்சா வெயில் காலமே முடிஞ்சிருச்சு. இன்னும் அப்படியே இருக்கு. அப்படிதான் நீங்க இன்சிடென்ட் பதிவு பண்ண முடியாது. பதிவு பண்ணிட்டியா? இல்ல அப்படிங்களா? The second one was if else, where Python chooses between two possibilities. But life is knowledge. So let me give you an example. Like suppose the university wants to assign grades. If the marks are above 90, grade supposed to be O. If the marks are above 80, the grade supposed to be A plus. If the marks are above 70, grade A. If the marks are above 60, grade B plus. Otherwise, grade B. Now tell me, can we solve this program using only if else? It's not efficient, right? So because there are more than two possibilities. Python gives another statement called if, elif, and else. So the word elif simply means else if. The Python checks the conditions one by one. The moment of one condition becomes true, the Python executes that blocks and ignores all the remaining conditions. Let's write the syntax first. If condition mean condition 1, then statement, then elif condition 2. After that, there will be statement, then elif statement 3, then statements, at last else with the final statement. So notice something important. Python checks from top to bottom. The order of conditions matters. So let's have a grading program. So where I'll be having first with an input marks from the user and input enter your marks. After that, using if marks are greater than or equal to 90, print grade O. elif marks greater than or equal to 80, print grade A plus. Then elif marks are greater than or equal to 70, print grade A. And then elif marks are greater than or equal to 60, print grade B plus. Finally, else print grade C. So if I save the program and run it and give input 95, it returns grade O. And if I run again with an input 83, it returns grade A. Also, if I give input 72, it returns grade A. Further, if I give 55, it returns grade B. So why didn't Python check the remaining conditions after printing A? Exactly, because once Python finds a true condition, it immediately executes the entire if-else block. It makes it efficient. So many students write conditions in the wrong order. So watch this carefully. So instead of marks greater than or equal to 60, instead of marks greater than or equal to 80 and then print grade A, I'm having marks greater than or equal to 60, grade B plus. And then the next statement I'm having the marks greater than or equal to 80, print A plus. After that, I am having if the marks are greater than or equal to, if the marks greater than or equal to 70, print A. And if I run it, enter your marks, I am giving input like 90, I mean, I am giving input some 85, it returns grade B plus. So instead of A plus, it returns B plus. Why it's so? Because the first condition itself becomes true. Python never reaches the second conditions. So always write conditions in the most specific to the most general or in the common logical order. So now let's learn another important concept called nested condition statements. Sometimes after making one condition, we need to make another decisions inside it. This is called a nested conditional statement. In simple words, an if statement, another inside another if statement. Let's understand with a real life example. Suppose the students want to participate in a placement. First condition, the student must have 75% attendance. If the condition is satisfied, then checks then another condition. The student's CGPA must be greater than or equal to 8. Only then the student is eligible. Now let's write the program. Attendance, integer, input, enter the attendance. Next, CGPA equal to float, input, enter CGPA. If attendance is greater than or equal to 75, if CGPA is greater than or equal to 8, then eligible for placements. Else, print CGPA is too low. And outside else will be print attendance is too low. Now ask the students like what happens if the condition is only 60%? Correct. Python never checks the CGPA, but the outer condition itself becomes false. Only if the first condition becomes true does Python enter into the nested if. Think of it like an entering a building. First, the security guard checks your ID card. Only after you enter the building does the receptionist ask your apartment. For one decision happens after another. That's exactly how nested conditions work. So, all three examples we have written today, like if, elif, if else, if elif else, and nested if, are collectively known as conditional statements. Why it's so? Because every statement executes based on a condition. If the condition is true, one path is taken. If the condition is false, another path must be taken. It's this eligibility to make decisions is what makes a program intelligent. Without conditional statements, every program would execute the same instructions every time regardless of the input. So, let me show you one more modern way of handling multiple conditions in Python. Instead of writing long if, elif, else chain, Python also provides match case statement. We will learn in the next one. So far we have learned several ways of making decisions in Python. We started with a simple if statement, then if else, followed by if elif statement, and finally nested conditional statements. For most situations, these statements are more than enough. But suppose we have a situation like this. Imagine you are writing a simple calculator. You display a menu. 1 means addition, 2 means subtraction, 3 means multiplication, and 4 means division. The user enters a choice. Now, think for a second, and one way is to write using if else, if elif, and else. Will it work? Yes. But when the when there are many choices, the code becomes long and difficult to read. To make such situations easier, Python introduced another decision-making statement called match case statement. So match case statement. This feature is available from Python 3.10 onwards. This purpose is to compare one value against multiple possible cases. The syntax looks like day equal to int input enter a number, then match day case 1 print Monday, then case 2 print Tuesday, then case 3 print Wednesday, then case 4 case default print invalid choice. So notice something interesting. Instead of writing many elif statements, we can simply write different cases. This case underscore acts as the default case. If none of the cases match, Python executes that block. Similar to the else statement inside the which we studied in if else. So let's execute it. So if I enter number 2, it returns Tuesday. So now again, if I run input 7, it returns invalid choice. So when should we use match case? Use match case when you are comparing one variable against many fixed values, like menu options, weekdays, months, or grades. For checking ranges such as marks greater than 90 or age greater than 18, if else is still the better choice. Now, as we understood match cases, let's move to our final concept of today's lecture. Have you ever played games where the computer chooses a random number, like guessing games, Ludo, Snake and Ladders, rolling a dice, online quizzes? Can a computer generate random values? The answer is yes. Python provides a module called random. A module is simply a collection of useful functions written by other programmers. Instead of writing everything ourselves, we can reuse their work. Before using it, we import random. Let's generate a random number. Print random dot randint 1 comma 10. So if I run it, it returns 6. And if I run it again, it prints 7. So let's run it one more time. it prints 3. And if I run it again, it returns 2. So did anyone get the same number as B? So this explains that every execution can produce a different value within a given range. Here, the range is random 1 to 10. So this means a random integer between 1 to 1 and 10, including both 1 and 10, is written using random. So let's build a tiny game like import random computer equal to random dot rand in 1 to 5. After that, guess equal to integer input guess the number. After that, if guess equal to computer print correct, else print wrong guess, print the correct number was. And if I run it, it says guess the number. I'm giving 5. It says correct. Now if I run it again and with a guess number 2, it says wrong guess and the correct number was 1. So this is very a small program, but it combines many concepts that we have learned today. This uses input, typecasting, random module, comparison operators, and conditional statements. Programming becomes is interesting when we combine multiple concepts together. So let's revise quickly. Today we have learned Boolean expressions, comparison operators, logical operators, conditional statements, if else, if elif else, nested conditions, match case statements, modulus operators, typecasting, and random module. Now, let me ask you few specific questions. Which operator gives the remainder after division? Yes, the answer is modulus operator. Which statement is used when there are exactly two possibilities? It's if else. Which statement is useful when checking multiple range? It's if elif else. Which statement is useful for menu-driven programs? It's match case. Which function generates a random integer? It's random.random. So this shows that we have understood today's concepts. For your practice after class, I want you to write these programs. Check whether a number is even or odd. Find the largest of three numbers. Display grades using if, elif, else statements. Create a simple calculator using match case. Build a number guessing game using the random module. These programs will strengthen today's concepts. So in this, let's try finding largest of three numbers. Here I'll be having input x with integer input enter num1, and after that I'm having y equal to integer input enter num2, z equal to integer input enter num3. So the condition goes like this: if x greater than or equal to y and x greater than equal to z, print x. Here elif y greater than equal to x and y greater than equal to z, print y. At last else print z. So if I save it and run the program, I'm giving input number 1 to 10, I mean number 1 15, number 2 10, and number 3 17. The output prints 17. So let's try run it. I mean let's run it. Let's trace what we have done in this program. So the first condition, if inside if I'm having x as 15 is greater than or equal to 10, which is true, and 15 is greater than or equal to 17 is false. So thus the if statement gets failed. So in the next elif y is greater than or equal to x, which is false. So immediately Python prints else statement. So I hope you understood the concept behind the first program. So now let's try simple calculator using math case. So the menu will be print multi-line string. 1 means add, 2 means subtract, 3 means multiplication, 4 means division, and then I'm closing the print statement. After that, I'm getting an input from the user. Enter your menu, and then I'm getting two numbers a comma b equal to integer input enter the numbers. After that, I'm having match x case 1 print a plus b, case 2 print a minus b, case 3 print a multiplied by b, case 4 print a divided by b, and at last case default print invalid menu. So if I run it, I'm giving menu as subtract, enter the numbers 2 space 5. Give me a minute. Let me save it. Enter the menu 1, enter the numbers 2. Let me try it again. Enter the menu 2, 2, comma 5. So for this, so the menu will be 2. The numbers entered are 2 and 5. So the output will be 3, minus 3. So let's try for multiplication. 5, 6, 30. Let's try with another input. Invalid menu will be the output, will be the exact option. So we have seen many programs like checking whether a number is even or odd, finding the largest of three numbers, display grades using if, else, elif, creating a simple calculator using match case, building a number guessing game using random modules. These concepts will strengthen today's concepts. In our next lecture, we will be moving to one of the most important topics in the programming loops. Instead of making decisions once, we will learn how to repeat a task multiple times efficiently. So thank you everyone. See you in the next class. Have a nice day.